So we're going to do a couple of examples just to demonstrate the use of the Legendre transformation. And the first example, I'm going to take f of x to be ax squared. So just to recall, we're making this function g of u of x and y to be f of x and y minus u times x, and u is defined as the partial of f with respect to x. There is no y variable here at all, so I don't need to be concerned about it. So I take my partial of f with respect to x, and I have that u is equal to 2ax, and so x is u over 2a. Okay, so we have our definition for x in terms of u. So I construct my function g of u, and I plug this value of x into my original function. So that's a u squared over 4a squared, and then I subtract u times x. So I subtract u squared over 2a, and this yields a minus u squared over 4a. And this is my new function after applying the Legendre transformation. So this was an example where we didn't have another variable y. So let's consider another example where we do have a function of these two variables, and I'm using ax squared y cubed. So now I will have a function g of u and y, which is f of x and y minus u times x. U is df by dx, and so that is 2ax y cubed, and so x is u over 2ay cubed, and I substitute that in for my value of x in my original function. So g of u and y is a u squared over 4a squared y to the 6th. And then I subtract u times x times y to the cubed. Yes, thank you. And then I subtract u times x. So that's a 2 u over 2ay cubed times a factor of u. So that y cubed changes that to a cubed. My a takes care of that, and I have a u squared over 4a minus a u squared over 2a, so I have a minus u squared over 4ay cubed. So this is now my new function, g of u and y. So the very next thing that we'll do is then apply this Legendre transformation to our Lagrangian so that we can replace the velocity with the momentum.